Artemis II rolls out to the launch pad. Europe's Comet Interceptor mission could fly a little earlier. NASA is racing to build a nuclear reactor for the moon. And in Space Bites Plus, bacteriaphages evolved in space learn to kill bacteria in new ways. All this and more in this week's Space Bites. We spent quite a bit over the course of last year talking about Comet 3I Atlas, and that's because we had this incredible new interstellar object passing through the solar system. But it was very far away, even at the closest point to Earth. It was just a tiny dot in even the largest telescopes. Wouldn't it be amazing if we could have quickly assembled and launched a mission that could do a flyby of the interstellar object as it was passing through the solar system? But we're not going to make that mistake again. The European Space Agency is building their Comet Interceptor mission. This is a mission that will fly out to the L2 Lagrange point, where James Webb and Euclid are, and then wait and loiter for the perfect opportunity. Either a long period comet or ideally an interstellar object. Then it will fire its engines onto an interception trajectory so that it will make a close flyby and be able to give us those first images of an object that came from another solar system. And in fact, the Comet Interceptor is going to contain other small probes, one built by JAXA, that will assist in these observations. And originally, the Comet Interceptor mission was supposed to be launched as part of ESA's Ariel mission, which is an exoplanet atmosphere studying mission that I'm really excited about, but these two missions were packaged together. But now it looks like Ariel is being delayed for several years, and instead of delaying the Comet Interceptor mission, they're going to bring it forward. One other advantage is it will have more room for propellant, so it will have a wider range of options for the kinds of objects that it can intercept. So we could see a launch of the Comet Interceptor sometime in 2028 or 2029, putting that Sentinel into space to take advantage of the next time an interstellar object passes through the solar system. I know it feels like it's been forever, but we are just around the corner from the Artemis II mission launching to the moon. This is when we're going to have humans climb into the Orion capsule that is on top of the Space Launch System. This enormous rocket is going to take off and go on a free return trajectory around the moon. It's going to carry 4 astronauts. They're going to fly farther from the Earth than any humans have ever been. And of course, to a place that humans have not been for about 50 years. They will take a bunch of pictures, experience the moon up close, and then come home. And the whole mission will take about 10 days. And just to show that they're serious, this is really happening, NASA just deployed the Space Launch System to Pad 39B on its massive crawler transporter. Took about 12 hours for it to make the journey from the assembly building out to the pad. So no earlier than February 2nd, we should see a wet dress rehearsal. And this is where they really just kind of take the rocket through all of the stages leading up to the launch, but they don't actually launch it. And then the launch window opens up on February 6th. And then we're going to have a bunch of opportunities for them to launch the rocket for the next couple of days. The problem, of course, with flying to the moon is that the moon is moving. And so you've got this ideal launch window, and then the moon is outside of that launch window, and you have to wait for the moon to return back to that same position. So we'll have a few days worth of launch window, and then we have to wait for the moon to return. And then a month later, there will be more launch windows. And of course, this is the first time that human beings have ever gotten onto the top of the Space Launch System, ridden in the Orion capsule. And NASA is going to be incredibly careful about this. So although they could launch as early as February 6th, I would be prepared for them scrubbing launches, putting in delays if anything causes them any concern. We've got great coverage about this upcoming launch from Matt Williams on Universe Today. China's Chang'e-6 mission brought us the first samples from the far side of the moon. Specifically, it went to a location called the South Bowl Aitken Basin. And in 2024, it brought back nearly 2 kilograms of lunar regolith and rocks. And this is the first time that we've had samples returned from the moon's far side, which of course has a giant mystery. We had never seen the far side of the moon until the first spacecraft, Luna 3, went beyond and gave us those first images. Unlike the side of the moon that we see, the near side, which is covered in these lunar mare, all of these ancient basaltic lava flows, the far side of the moon is just pounded by craters. So why did we get volcanism on the near side, but we didn't get it on the far side? There have been a lot of explanations proposed for why we might see this, but it appears that the Chang'e-6 mission has given scientists a pretty compelling answer. In the samples from Chang'e-6, there were samples that clearly had been dug up from very deep inside the moon. The impact that caused the South Pole Aitken Basin was gigantic and dug deep. And during this impact, a lot of the volatile elements that were present in the mantle and the crust of the moon were dissipated off into space. And now it appears that this giant impact and the loss of these volatiles from the crust of the moon suppressed volcanic activity on the far side of the moon. And so this is why we don't see all of this volcanic activity back there. We've got a story about this from Matt Williams. Now, that was the moon billions of years ago, but the problem that we have with the moon today is trying to explore it, and that is because it has this very long lunar night. So it takes about 27 and a half days to go around the Earth, and for half of that time, any spot on the surface of the moon is in sunlight, and then the other half it's in darkness. And when it's in darkness, the temperatures get very low, and that kills batteries, destroys electronics. And of course, we've been covering this mission after mission, where all of these missions land on the surface of the moon, they do their work during the lunar day, and then they die during the lunar night, and they don't come back. So you need some way to keep your spacecraft warm. Think about what will happen when we have an actual lunar base on the surface of the moon. We need some base load power. Now, one option is an RTG, a radioisotope thermoelectric generator, where you've got a decaying chunk of plutonium. You take the heat, you turn that into electricity, and you can use that to keep your batteries warm and so on, or even just use the heat coming from the plutonium itself. But the answer really has got to be nuclear power, a fission reactor on the moon. And this is something that NASA has known and has been working on for a very long time. They've been working with a bunch of contractors to develop what they're calling the kilopower nuclear reactor. And this is something that would provide base load power on the surface of the moon in the thousands of watts, which would be enough to power science instruments, help support a base of humans on the moon, and build up this infrastructure for our exploration of the moon. Last year, we saw that a lot of NASA's space-based nuclear power ideas were put on the back burner by the administration. But now we've got a new NASA administrator, Jared Isaacman, and he's really interested in researching nuclear reactors for the moon. And so now NASA and the Department of Energy have put out a new memorandum of understanding. They're looking for providers to help them develop a fission reactor that would go to the moon. And they're hoping that this will be completed by 2030. This will be just in time for the next, probably longer term Artemis missions, where the astronauts will need some kind of support from the lunar surface. We've got a story about this from Andy Thomaswick. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner last week by a landslide was that NASA's budget is safe. So thank you everybody who voted for that story. Now we're going to post this week's story into the post tab at the moment you're watching this video. So go there, vote, definitely subscribe to the channel, and click on the notifications bell to know when we release more of these. Enceladus is one of the most exciting places here in the solar system. And this is because there are plumes of water ice that are being blasted into space. And not just plumes of water ice, there is also dissolved hydrogen gas, there are various organic molecules. There's a lot going on in these plumes that Enceladus is sending out. Maybe these plumes are connected to a subsurface liquid ocean of water. And of course, wherever there's water, there could be life. And so this is one of the best places for us to search for life in the solar system. But is there life down there in Enceladus? Well, we don't know. The only way to know would be to send a spacecraft to Enceladus that has the instruments on board that would be able to measure the composition of the plumes and know if the conditions, at least down there, are amenable to life. You're looking for pH values to be within a certain range that life can live within. And then theoretically, as these plumes are coming out of Enceladus, the material is falling back down around onto the surface of Enceladus. So if you have a spacecraft that is able to take images of the surface, it could measure the pH of what's down in the oceans just by looking at what's on the surface. This is using a technology called a Raman spectrometer. And so researchers have been working with potential Raman spectrometers to see if they could do the work. Could you send one of these to Enceladus? Would it get you the pH of what's down there under the ice? And then point us in the direction about whether or not there might be life down there. We've got a story about this from Lawrence Tugnetti. Now, this runs counter to the interview that I just did with Dr. Paul Byrne about the potential habitability of Europa, which is one of the moons of Jupiter. And in this case, it looks like there isn't a known process that could cause the hydrothermal vents on Europa that would lead to life being able to form there. But over on Enceladus, the plumes are happening. The evidence is there. And so we just have to look at them. So definitely check out that interview that I did with Paul Byrne. And we actually specifically address those differences between Europa and Enceladus. All right, as you know, I like to show you amazing pictures, and I've got a bunch of zingers this week. So first up, this is the Helix Nebula taken by James Webb. And the Helix Nebula is probably the best example of a planetary nebula, something that we can see from here on Earth. I've taken pictures of it with my telescope. You can too. It's very easy to find. And planetary nebula, they are caused when a star like our sun dies. It bloats up as a red giant, and then it puffs out these outer layers into space. And once it has gotten rid of all of its outer layers, you're left with the core, what was once where all the fusion was happening. That's a white dwarf. And you have these outer layers of the star just drifting off into space. Now, this image from James Webb is off the hook. And especially when you zoom in to some of the smaller components, you can see these individual little blobs, tens of thousands of little blobs of gas, each of which is bigger than the solar system or bigger than the orbit of Pluto, and yet has much less mass than the entire solar system. And then you can compare this image taken by Webb to the one taken by Hubble, to the one taken by the Spitzer Space Telescope. It's an incredible image. Got a story about this from Evan Goff. And then here's another image. This time it was taken by the Hubble Space Telescope. And this is a star-forming region called Lupus 3, and it's only about 500 light years away from Earth. So that's like right in our backyard. And you can't get a sense from this image the larger structure. So there's some other images that we're going to show you where you can see the sort of central region as well as the dark nebula that is around it, filled with cold molecular gas. This is hydrogen that is opaque, and so it makes the stars behind it seem to disappear. And this is a common thing that we see in star-forming regions. But then you've got intense radiation coming from these two stars. They're called T Tauri stars. They're a kind of young star that is putting out so much radiation that you've got this bright nebula. And it's an example of a reflection nebula, which is also kind of rare. And I really enjoy reflection nebulas. So definitely check out this story again from Evan Goff. And then this image is really cool. So we know that the Milky Way is this giant spiral galaxy today. It is essentially as old as the universe itself, and we've got about 100 billion stars in the Milky Way. But it grew over time through mergers of other dwarf galaxies, as well as just star formation of all of the gas that was present in the Milky Way. And so we can look back in time and think about what the Milky Way looked like historically. And so this image that you're looking at was put together by a bunch of researchers where they calculated the amount of stars in the Milky Way at different ages in the universe from now all the way back to just 1.5 billion years after the Big Bang, a time when the galaxy only had about 100 to 300 million stars, a thousandth of the stars that it has today. And then they went back through archives from James Webb and found examples of each of those galaxies at that time, and then put it together into this really cool historical image of what the Milky Way might have looked like over time, from pictures taken by James Webb. Now, I was so entranced by this picture that I reached out to the researcher who coordinated bringing this picture together, Dr. Vivian Tan. Here's what she had to say.
If we're using that analogy, like you just meet some person on the streets of Toronto, let's say. I mean, I'm from Toronto, so I'm, sorry for using that city as an example. But then,
the more Canadian references, the better on this channel.
Oh, that's amazing. Yeah. So, you meet someone, let's say they're like kind of middle-aged. So this is like, the Milky Way. And then like, you're like, oh, do you have any like photos of when you were younger? And they're like, oh, sadly, I don't. They all
Right.
like burned in a fire. But then, you know, you like go to like their family members, friends when they grow up, and then you ask them for like kid photos and like teen photos. And then from there, you can sort of kind of piece together what this stranger without any kid photos would have looked like as a kid.
Now you're watching this episode here on YouTube, and you probably watched some ads at the beginning of this episode, and there might be ads at the end of this episode. We can't turn those off, but there is a place where you can go and you can watch this exact episode, but with no ads, completely for free, and that's over on Patreon. And we really think that Patreon is the best place to watch, especially with the bogus copyright claims that we've been having to deal with. You just watch our episodes over there, subscribe to us completely for free. You don't have to donate anything, and you can watch it over there. I'm going to put a link in the show notes, and as a reward, you've got one additional story in every single Space Bites over on Patreon. And this week's story is about how bacteriaphages were sent to space and they learned new tricks to kill bacteria. But if you want even more space news, this is just a fraction of the stories that we're covering over on Universe Today. And every Friday, I write my email newsletter, which contains a summary of every single story that we covered this week over on Universe Today. It's completely free. I write every single word in the newsletter. You can go to universetoday.com/newsletter to sign up. I'm going to talk about a new smart telescope that I got my hands on, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Bear Lake Roofing, Brian Bodie, Caradon, Chuck Hawkins, Commander Bailock, Cy Nelson, Dark Finga, David Gilton, and David Maz, Evan Pro, Greg Feely, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Sitz, Michael Purcell, Nordspace, OneStepForAnimals.org, Paul Roebuck, Rinkaidu, Richard Williams, Sean Sargent, Stephen Fallon Munley, Team 49, Telescopes Canada, Wolfgang Klotz, and Zelda Board Galactic Defender, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So I've got my hands on another smart telescope. Of course, I've got the Sea-Star behind me. I've got the Vespera, and now I've got a Dwarf Mini. And this is a telescope produced by Dwarf Lab, and their previous one that you're probably more familiar with is the Dwarf 3, and it's already pretty small, kind of comparable to the Sea-Star. And now it's just ridiculous. So the Dwarf Mini, this thing could fit in my pocket, and yet it is a smart telescope. Let's see. And I got it yesterday, and we had one last night of clear skies in this sort of series that we've had. And so I was only able to work with it for like maybe 10 minutes last night. And I put it out for 5 minutes. I took this image of the Orion Nebula that was up. And it's good. It's not bad. Like I can't even imagine how good this would look if I set it out for hours and hours and hours. And this thing is totally portable. You can put it on top of an existing tripod, or you can even just sort of sit it on the ground with its own little base platform. And the software sort of checks off what I consider to be the most important thing, which is that it connects to your Wi-Fi. So then you don't have to tie up your phone's Wi-Fi connection to be able to use it. And so you go through a configuration initially, and then you transition it over onto your home's Wi-Fi, and then you can just continue to use it. It's got a really nice intuitive catalog. I'm really excited to start playing around with this telescope, and especially to be able to like take it places. Right? If I'm going to go on a trip, go back to Iceland, I can just take it with me. So I'm pretty amazed at this so far. It costs about $549 in Canada. It's available for pre-order right now. So I don't know what that is, like about $400 in the US. So it is also probably the most affordable smart telescope that's on the market right now. Now, I haven't had a chance to really kind of dig into it. Of course, I will be folding it into my larger coverage of these smart telescopes in general. You should definitely check out Trevor's review over at Astro Backyard. He goes into a lot of detail, puts it through its paces, downloads the images, processes them with the software on his computer, and can give you like a much better explanation of how well this thing works than I do. So just to be clear, this is not sponsored in any way. They haven't paid me to say any of this. They did send me a copy of the telescope, but they're not going to be influencing any of our content. And in fact, we also got one in the hands of Dave Dickinson, who does all of the amateur astronomy articles on Universe Today, and he's going to be giving his review shortly as well. All right, we'll see you next time.